This video is going to give you a brief introduction to beta plus decay. To begin with, let's look at a little notation for chemistry. I've got my element, I'm going to call it X, and to the left of that, on the top I'm going to put nucleons, and towards the bottom I'm going to put protons. This isn't a fraction, it's just one number over top of the other. And remember, the nucleons are all the particles in the nucleus. So let's look at helium as an example. Helium has 2 electrons, 2 protons, and 2 neutrons. So in the middle of the helium molecule, I've got 4 nucleons, 2 of which are protons. 4 over 2, and the symbol for helium is He, capital H, little e. So I'll write it as 4 over 2 He. Now let's look at the beta plus decay, and now into the how the notation works. So I'm going to look at carbon. In fact, I'm going to look at carbon 10. So this has 10 nucleons, 4 of which are carbon. So in my model, I haven't really indicated that I have only 4 neutrons, but it's just a generic model. So 10 over 6 carbon, and that's going to create 2 products. One is going to be a positron, and the positron is an electron with a positive charge, and the other is going to be a neutrino. A neutrino is just a little piece of energy. It doesn't have any charge, and it has such a minuscule amount of mass that we'll just say it doesn't have any mass. It's just a small piece of energy. So positron and a neutrino. Now a positron isn't a nucleon. It's not found in the nucleus. So when I'm counting out the nucleons, it's 0 because it's not 1 itself. But it does have a charge of +1. That is the same magnitude as a proton, and it's positive just like a proton. I wrote down as +1 instead of just 1 to really emphasize to you that it's a positive 1. But you could just write down 1 and that would be fine. Let's balance our equation. So I put my products over here that came off, and I've got 0 over 1 is equal to E plus a neutrino. Now let's balance the equation. So if I look at this, conservation of mass, I've got 10 on the left, and on the right I've got 0. So what plus 0 equals 10? Well, that's going to be 10. And then underneath that, I'll do conservation of charge. On the left it starts off with 6 positive charges. On the right I have 1 positive charge. So what plus 1 equals 6? And that'll be 5. And because the number of protons determines the element you have, what has 5 protons on the periodic table? It's boron. So boron has 5 protons. Now I've been able to balance my equation. So one more thing you might be wondering is, where does the positron and the neutrino come from? Well, if I look at the charges, I kind of have a clue. On the left-hand side, I start with 6 positive charges. On the right-hand side, I end up with 5. So I lost one of the protons. That positively charged proton turned into a positive positron. And the masses didn't match, so that little piece came off as the neutrino. But if I look at the charges, you can see how they still balance, and so I'm still conserving charge in this whole position, this whole process. Sorry.